We have some with a laptop, some with a coffee, but overall, the Ox character looks pretty good. So this is kind of what I'll be showing you how we get from some synthetic data to a fine-tuned model. And this was only fine-tuned on. Welcome, everybody, to Fine Tuning Fridays, where each week we're going to put a small model that you can train within a couple hours head to head against a large model, such as like the OpenAI series or Anthropic or one of these foundation models. And each week we're going to pick a task, dive in and see if the small model can be competitive with the big model and kind of narrow down the task to make this possible at all. So today we are going to be taking on the task of fine-tuning a small diffusion transformer, or you'll see me abbreviate it as DIT as we go along, to generate OpenAI or hopefully OpenAI level images. And we're going to do this by distilling off of synthetic data from OpenAI itself. So you'll kind of see how this pipeline all connects together. But the end goal is to have a small, fast, cheap model that we can use to generate brand images like the one below. We're doing a little work on branding the Oxen AI character. This is one of the ones that has been proposed of this kind of like white, fluffy Himalayan ox who likes to live up in the mountains. So you'll see we kind of haven't had very consistent branding in a lot of our assets before. So we're trying to train a model to be consistent and generate images like this. And for context, we've actually been trying to do this for a while. Actually, I'll start with the formula. So if you missed last week, this is just going to be the kind of consistent formula that we're going through. So we'll define our task, we'll collect a data set, we'll eval our open source model, eval closed source model, fine tune the open source model, eval the fine tune, and declare a winner. So these will be the consistent steps that we go through. And today's task is this image generation one. So for context, we have tried to do this in the past with, I think this was about a year ago or a year and a half ago. And the models weren't very good at this point. This was our same prompt and same kind of character. You could see he's all over the place and couldn't get a very consistent scene or model. We've actually been using this guy down in the center for our 404 page for a while. He's kind of just hanging out in a missing page there. And out of all the ones that we generated so far, that was kind of the one that's stuck on the site. This is what the 404 page looks like. And recently, OpenAI released their image gen model, which actually has been giving pretty good character consistency, but it's not perfect. And so this is just like a screenshot from my library of images that I've tried to create, either for these fine-tuning Fridays or for other things. And you can see there is some level of character consistency depending on the prompt that I use. But you get weird things like sometimes the ox will be super young, sometimes the ox will be super old. Trying to like prompt your way out of that can get tough because you don't know like how old it's going to get or how young, or sometimes it makes it a little too white and cartoonish. Sometimes it makes it a little too like yellowy tinted vintage. So you can kind of see like we're on the right track here, but not quite the consistent character that we'd want to use. These ones in the upper left are starting to get closer to that, and I'll kind of show you how we got those and then how we'll use this for synthetic data to train our own model. So before we dive in, I kind of want to give you a live demo of the model that we did train. So I have this notebook up and running. I actually think I downloaded the model weights here and have it running. So would love some crowd participation of what we want to make the ox do. I'll just have him drinking coffee at first, but would love some random other prompts from the crowd. So as you can see, this is a diffusion model going through 20 steps of uh, diffusion, and at the end, it's going to generate 4 images, and they're all pretty consistent, all an ox drinking coffee, and this model is like something you could download and run yourself. So does anybody else have a prompt that we want to put in just to kick this thing around? Matthias, you got something fun?
Let's see. Can we do
Holding a hockey
him
stick
climbing a
up.
mountain, the side of a mountain, or just one? Yeah, climbing a
Yeah,
mountain.
let's try it. And you can see under the hood, I generate a little more specific prompt here. So it says a 3D Pixar style white furry ox character climbing a mountain. And boom, we got him on top of a mountain. Pretty cool.
Nice.
Holding a hockey stick is another one here, the chat. And if you've done this in the ChatGPT uh, interface, you'll know that those, or the newest image gen model takes like 40 seconds to a minute to do its whole process, and it'll only give you one image out at the end. Okay, it's having a hard time with the hockey stick. I feel like this fine tune has done a good job with the character consistency and starting to work on the different props that it's holding. Um, we'll do uh, with a laptop and coffee while wearing spectacles. It's the last one from the chat. Um, so it's a bit quicker to get more options, and we've kind of fine-tuned it just to be in this style and to only generate on white background. So we have some with a laptop, some with a coffee, but overall, the Ox character looks pretty good. So this is kind of what I'll be showing you how we get from some synthetic data to a fine-tuned model. And this was only fine-tuned on about 2,000 examples. So I think that's the main reason that it has a hard time with the props is like it just hasn't seen enough variety of the props. If you keep it a little more simple, like typing on a laptop, these are the types of things that I did train it on is just like verb, noun, and maybe some adjectives in between. And that seems to be the sweet spot for the model right now. So even put the Apple logo on some of these. So not too shabby, and you can see he's pretty consistent. So that's the motivation. All of this code I have up in these Marimo style notebooks, which are fun, and I'll show you how to use them as we go along. But that's kind of what the output is going to look like. So let's start by deciding how you choose the character. So at the end of the day, what's really cool about this pipeline that I put together is all you really need is like one reference image at the start. So to motivate this, we had this 404 ox that we kind of like the style. You can see it's a little older of an image gen model. I think it might have been Mid-Journey or something like that. And so the first thing I did was just, hey, can we extract that ox from our old 404 scene and just leave him on a white background. So this is kind of the reference image that we're going to start with. And the new ChatGPT image gen model actually did a pretty decent job of just extracting him from the background. You will notice that his eyes are a little sleepy, or as the oxen herd likes to joke, he's a little high. But that's what we're going to start with, and you can see how that kind of like cascades down into the training data and how we fix it. But this is really the starting point here.
Dude
The
is
next,
blazed.
yeah, he's having a good day. Um, Josh also joked this is what he looks like when he's not had his coffee in the morning or having his first coffee. So that could be it too.
Or when he's having a good day.
Having a good day. So the first thing I did was put this back into ChatGPT because I did a few iterations of like trying to articulate what all of the different characteristics that we wanted out of this ox was. And I was like, why not just use a visual language model to do this? So describe the style and texture of this image in as much detail as possible to be able to recreate it from a prompt in an image generation model. And so it gave me this nice, very descriptive prompt back of a cute 3D Pixar style white ox standing upright on two legs, et cetera, et cetera. It goes into like soft, realistic texturing and light shading, giving it a plush, huggable appearance. These are all things we could potentially tweak in this prompt if we didn't like the huggable appearance. Maybe we wanted it to have like more of a outdoor wilderness vibe. But this at least gives us a nice prompt template that we can tweak and get the characteristics that we want. So now we have a reference image and a very descriptive prompt, and we can be off to the races to generate some synthetic data. So if you've been following any of the research or come to the archive dives in the past, one of the best things that ever happened to fine-tuning smaller models was having the large models at our fingertips via APIs. And we even see this in some of the DeepSeek work where they train, the massive DeepSeek R1 and then use that to distill and fine tune much smaller versions of the model, like an 8 billion or a 3 billion parameter model. The Quen series of models does this as well. And there's nothing kind of stopping you from just using the API to generate synthetic data. So the more synthetic data, the better. And so the next experiment that I wanted to run was like, can we take this descriptive prompt and the reference image and put them together and create a semi-consistent set of characters? And the short answer is it actually worked extremely well. And so I'll start with the data set and then we can go into the code that I use to actually generate it. But the idea here is I generated a bunch of actions. So like walking a dog, juggling pineapples, leaping over puddles, dancing with a broom. I also used an LLM to generate all of these things. I didn't manually put them in one by one. But you can see we've got a variety of prompts. We've got a variety of ox. And at the start, he is still pretty sleepy. His eyes are closed a bit. And I put the full kind of like descriptive prompt that I got from ChatGPT earlier in here. And I started to iterate on this a little bit. Like if we go a little farther into the training data, I added the word handsome, and then I said his eyes should be wide open and happy. And now we've kind of gotten rid of that sleepy nature. It's still there a little bit, but like overall, these are pretty consistent oxen doing a variety of different things. The problem is you still have to kind of use OpenAI to generate these things. And I'm super curious if we can put this into a small language model and have it just do this task, because if we can do that, we can do something pretty cool downstream, which is our own little reinforcement learning loop. If you followed us, we covered techniques such as DPO and GRPO, which are reinforcement learning pipelines. And my idea later on is to take this model and have some sort of reward model that sits on top of it. It could be a visual language model. It could just be like human feedback where we're labeling these things, but have the model generate an image and then have that reward model say, is it the character we like? Is it doing the action that was described? Is the lighting and texture good? What other things are off about it? So maybe this guy's too high. Maybe this one isn't on a pure white background. This one has 3 legs. These were all generated in that data set that we saw from OpenAI. And I think these are the types of things that with a reinforcement learning loop at the end can kind of like sand off the edges and make a really good local model that like just does this one task. Um, and that's something you can't really do if you don't have access to the model weights itself. So that's kind of the motivation. The other motivation is just to have the iteration cycle a bit quicker because sometimes I'll just sit there like waiting for the progress bar to load on OpenAI, and it takes up half my day just trying to get a good a good aux to put in our branding assets. So let's dive into the code for generating this synthetic training data. So I will go back to here. This repository, it's just OxenAI DIT training. If you guys want to follow along, I'll actually put it in the chat here. And all of these scripts you can just download and run, or you can run it on OxenAI itself. So we'll look at the synthetic data script. All of these things are using Marimo notebooks, which if you haven't used that in the past, is kind of like a Jupyter notebook. But it has some advantages of just being raw Python and uh, running in a kind of a directed acyclic graph so that all of the nodes run in the correct order. Um, so the first thing I need to do here is grab an OpenAI key, OpenAI API key. Um, and we have a few different things that this notebook can do. One for debugging, I just have the same kind of thing where we could type in a prompt um, and see it generate an image. So let's start with what was one of the ones that it failed on before, holding a hockey stick. Stick. We'll hit generate, and you can see it starts by generating that long prompt with inserting holding a hockey stick down here. And now it's going and hitting OpenAI's image gen endpoint. And let's skip down to that code to kind of show you how easy that is. So this is my generate and save image function. We have the prompt here where we're interpolating the action that we want. Um, we have an OxenAI repo that I'm going to save this image back to so we can look at that at the end. And then this is the code to call OpenAI. So we're using GPT image gen 1, and you can just pass it in a file handle to that reference image, which we also have stored in this repository. So I have like images, reference, and our base aux here, which is kind of that first guy that I tried. I do want to try this pipeline with other reference auxes, like maybe this guy that's just has his hands to the side. He also has that yellow tint that I don't love. But you kind of, whatever base image you want here, I'm just downloading the reference base aux and putting it in there. You're going to get back a base64 encoded image. I then save that image to our images generated and have some sort of image ID there. And then I also append a row to our data frame, our training data set. And at the end, which I think it probably should have finished by now, you can see I have a commit 1 minute ago to this training data set where he is holding a hockey stick. And if I kind of skip to the end here, boom, this is the OpenAI version. And they do, I mean, they do a pretty good job of consistently generating the things that we want to. Like I said, we're just using this as synthetic data. And it's nice to have this script where now I can see all the ones that it messes up on. I could go add that to the training data and train another model. Um, so that was kind of like one-off prompting it. To generate all the different actions, I created a list of verbs that I wanted it to do. So like running with a, putting together a, working on a, etc. We could add to this list until the cows come home, pun intended. But this is making another OpenAI API call, and it says generate a verb and noun action pair that a character could be doing in a scene, such as, and I give it a few examples. Um, I also say do not use any of the previous actions listed here, which I just sample some of the previous actions. I didn't want to put all of them into the context because I could see that just exploding, but just to try not to generate the same thing over and over again. Um, I also add a random seed to the start, and this gives it like enough randomness that we got a pretty good distribution. I mean, if you look at the actions that it's doing here, it's like a lot of different objects of different colors. The ox is doing a lot of different types of things. And if we wanted to do some of the more complex actions, I could imagine tweaking the script to like generate two things in the scene and have a color and have some sort of other adjective connecting them. But basically, I have that function to generate a one-off image. You can see it takes like 30 to 40 seconds to generate each one of them. Or I have this button to just like put that in a loop, generate a random action, and then generate and save the images. So we could kick this off and you'll see it kind of grabs all of the ones that we had before, generates a new one, drawing a red sunflower, and then this is going to hit OpenAI and you can just have this in a loop that's generating synthetic data. So we'll let that run. Maybe we'll get some more training data as we go along. Um, but that's kind of all you need is a reference image. I should probably put reference image here. Reference image, prompt, generate list of actions, and then generate the image with the reference image and the descriptive prompt. Um, cool. That is the training data half of it. And so now that we have like a solid starting data set, we need to pick a model that we want to fine tune. Um, so the model that I decided to start with was one that I had a little experience fine tuning in the past. It's this PixArt XL2 model. This is the diffusion transformer. And a few things that I like about this model. Uh, One is it's super efficient. This was from about a year ago when they trained this model. So they're comparing it to things like Stable Diffusion 1.5 or Dolly 2. But you can see they really focused on getting this model small and efficient and fast. And so we're not doing like a full training run here. We're not going to be spending $28,000. We let them do that half, but we can take these pre-trained weights and fine tune them with a parameter efficient LoRa. And you can see when we get to that point, depending on how much data you have and depending on how many epics you run it on, you can with the 2000 examples and one epic, I trained a model in under, I think, under 5 minutes. So pretty quick, pretty efficient, and that's why I chose this model at the start. Um, and so let's dive into the fine-tuning script to show you how that all works. So I have this notebook in here called train.py. Let's launch it. I did spin this up on an H100 with pretty beefy specs here. We probably don't need it for more than an hour. Does cost like $7 an hour if you crank this up. If you have less CPU cores or less memory, you can kind of optimize there. But I wanted this to go as fast as possible, and you'll see we can train a model in like a couple minutes here. So we'll let this boot up.
Brett,
Any
a quick,
questions?
quick question from the chat. How much did training cost?
Yeah, so you can see this machine is like $7 an hour. And the big, I think it actually takes just about as long to download the base model weights as it does to train the model for one epic. So I'll kind of walk you through all of that here. But, if you do it for one epic, it is less than $1. If you want to do it for like 50 epochs, it might be $10 or something like that. Um, the other price that you have to take into consideration is this loop right here. When we're calling OpenAI to generate the synthetic data, that's a decent amount of tokens there. And I think for the 2,000 rows that I generated, it was about $80 to generate all of that data. So this is actually potentially the more expensive part is generating the synthetic data. So maybe I'll stop that to save us some money. Close this guy. Um, cool. So let's dive into the training script. One nice thing about Marimo notebooks is you can see you can add these what are called run buttons. And since all of the cells are connected in this graph, um, you can do things like start loading the model and then go down later on in the script and start working on your code a bit, but pause the execution of the lower cells until that top one is done. And what this was super handy for as I was training is like sometimes if you just have like a Python script to train, that model loading part does take a lot of time. Uh, and so if you're like progressively iterating on that and having to load the model weights every single time you kick off your script, that's just killing a couple minutes every time you want to debug. So these notebooks are nice to like load all of the model weights into memory at the start, that expensive operation, and then start tweaking and writing the rest of your code down below. So I found that pretty handy as I was going along. Um, but let's start with loading the model. So if you look at the architecture of this model, you'll see there's like a few moving parts. Um, there's a text encoder, there's a variational auto encoder, and then there's the diffusion transformer itself right here. So the text encoder was a pre-trained language model called T5. This is a slightly older but small language model, I think from Google, that encodes the text input. Then they have a pre-trained variational autoencoder. If you're not familiar with VAEs, that's just kind of like an autoencoder takes an image, compresses it down to a latent space, and tries to reconstruct that same image. So you can pre-train this just on like a variety of data without actually having any labels, which is great. So they have a pre-trained variational autoencoder. You can see if the parameters are in blue, that's frozen parameters. If it's in orange, those are the parameters that we're going to tune. So the things that we actually tune are within the transformer that sits on top of those uh, text encoder and the variational auto encoder. And we're going to do a LoRa or a low rank kind of set of parameters on the side. So this is going to be a really lightweight set of parameters that we're training. And those are kind of like the different components of the model that you have to load. So I forget where I kicked that off here. So you can see we start by loading the text encoder, loading a tokenizer, loading the variational autoencoder, and loading a transformer model. All of these are Hugging Face classes, like the autoencoder KL transformer 2D model, which is your like image generation transformer or image processing transformer. You also need this noise scheduler and the tokenizer, and you need to set up what parameters within the model you want to fine tune. So this is kind of from the PixArt repository. These are the ones that they suggested that you tune, but you could only fine tune the linear layers if you wanted, or only fine tune the keys and values and queries if you wanted. But this load model function will return our noise schedulizer, our tokenizer, our VIE, text encoder, and transformer. And let's see, that looks like it's all loaded. And you can see we have 13 13 million trainable parameters, 600 million parameters in the model in general. So it's like 2% trainable parameters, which makes this like a really lightweight, quick training job. I'm also going to kick off the loading of the data set, which is going to go and download all of those images, download our training.parquet file, and put all of that kind of together in a way that we can load into our training loop. We have a few like data processing functions, combining the inputs and outputs that we want, tokenizing the images. Um, One thing to note here is in this tokenized captions, you'll notice that the training data itself um, had just this action right here. So it has a column for the action, which is like working on a yellow bicycle. Um, but we also want to put that in the context of another like uh, set of words or prompt. So this is really the user input that I'm expecting, and I think actually constraining it to just the action that we want the aux to do is nice for a branded like image generation model because we can have the team just type in the actions and not really have to worry about all of the other verbiage on the side. Because that's kind of where I saw these image gen or the images that we generated with ChatGPT start going off the rails is because like one person on the team would use these verbs and another one would use these adjectives, et cetera, et cetera. So kind of limiting the user input to just this and under the scenes putting together like a more descriptive trigger prompt. So this is really the only input that we're going to be taking from the user. Um, and then looking at the training loop itself, if you're not super familiar with the diffusion models, it's good to visualize what's going on here before we look at the training loop. So let's see. With diffusion, what you're really training the model to do is like take some noise or take an image that has some noise inside it and have the model predict how much noise is in the image. And then we can just like subtract that noise from the image over and over again until we get like a really high quality image. So you kind of start with this big blurry blob and then end up with this image over those 20 steps as you're going along. You can also have it be like a blurry blob and a text prompt in our case. And then the text prompt goes in, you extract some features, put that into the latent space, and then do this whole process. But when we go into our training loop, you'll see that we take in our noise scheduler and all of these different components of the model, and we have to wire them together in this loop to slowly train the model over time. So a lot of this is just like setting up how many epochs we want to run, setting up the training batch size, and I see a question in here. I thought that the PixArt model already had all of those component models like VAE, text encoder, etc. But your load model function was loading them separately. Why did you do that? That's a great question because you'll kind of see it in here. I wanted to show like the full training loop of how you use all of those individual components together to get your loss function and then train the model. There might be like a diffusers pipeline that does all of this for you. There definitely is for inference. But I think seeing under the hood here and seeing how they all tie together will help us in the reinforcement learning step, which we're not going to do this week, but in the future, so that we kind of have lower level access to those things that we want to optimize. So we iterate over our training data loader that is going to be loading all of those image and prompt pairs. We'll get a batch out. In this case, I was using a batch size of 8, but depending on how much GPU VRAM You can do larger batch sizes if you want. Marimo is also nice. It kind of has these indicators at the bottom of you can see how much GPU VRAM we're using. And this is interesting. It says we're on an H200 right now with 140 gigs. I thought I spun up an H100, but that is a beefy machine. Um, we'll then take in that batch and extract uh, the pixel values from it and run that through the variational autoencoder to get out all of our latent parameters. So that's this step right here. It's passing in the image and getting out some sort of latent vector that describes the image. We then sample some noise. So there's a few different ways that you can sample the noise. I took this from uh, from the PixArt training repository. Um, so the first thing that you want to do while you're training is you're actually just like sampling a random timestamp for each one of these passes, and you're going to add that amount of noise to the image. So during inference, we do go from like very noisy all the way to the image, but during training, you kind of sample a random step within here. So you might sample like somewhere in here, add that much noise, and then ask the model to predict that noise from there. So that's what we're doing here is getting the noise, we apply it and combine it with the prompt that we get, or the prompt embeddings that we get from our text encoder. So you can say, see, here's the variational autoencoder. Here is the language model that we're embedding the prompts with. And then we combine that all into these noisy latents that we're going to pass through the transformer that will then give us a model prediction out. The model prediction is actually just like trying to predict the noise. And then we take the mean squared error of how much noise the model predicted and the target, which was the noise that we passed in. That'll give us our loss. We'll then call loss dot backwards, and then there's a little gradient clipping here. But that's pretty much the whole training loop is sample some random noise, combine it with the text encoder embeddings and the variational autoencoder image embeddings, and then try to get the model to predict that noise back out from the latent space. So that is kind of the full pipeline at the end. We then just save the LoRa weights that came out. So if you remember, we loaded all of those different models at the start. We have this transformer, and then this is like the full transformer. I actually didn't cover this before, but you can call get PEFT model on that transformer. PEFT stands for parameter efficient fine tuning. Give it your LoRa config, and then you get out a transformer that's kind of like wrapped in that parameter efficient fine tuning. And that's what we're returning here. So at the end, this stable diffusion pipeline has this function called save LoRa weights that will just save the LoRa weights and not the entire model, because we didn't actually update the entire model. We just updated these like small weights on the side. At the end, it then commits those model weights back to Oxen, and you'll see I have a few different experiments here. I actually ran the model for 1 epoch, 20 epochs, and 50 epochs, just to see if there was any change in how long we train it or how many times it sees the training data affect its performance. And we'll look at the results there in a minute. But now that all of this has been loaded, let's see. We're doing this for 50 epochs. Maybe I will change this just to be 1, so that we can see how quickly it goes. I'll click train model. You can see we have 2011 examples here. batch size of 8. It's loaded all the data. It's starting to go through the training pipeline, and it's going to take about 2 minutes to complete here. So pretty quick to go through entire epic with those 2,000 examples. You can also monitor things like the GPU usage down here. So we're using about 30 gigs of VRAM for a batch size of 8. So you could probably run this on a much smaller GPU if you wanted as well. So we'll let that keep running because it's going to dump us a new model at the end. Um, and so what I did from there was that same inference notebook that we had. So inference DIT. There's actually two different ways that you can run it. Um, so let's spin this thing back up again. There's in the mode where I'm just typing in one phrase at a time and getting that uh, grid of images out. And then I also use that same function to be able to run over an entire data set, so like list of prompts, and generate an image for each one of those. So it takes a second to boot up here. But once it does, I'll show you that loop, and then I'll show you the outputs from this model. As Marimo's booting up, one nice thing that I like to monitor on the side is there's these like little green icons that tell you when the cells are ready. Um, and so you can see I clicked load model, and there's like, it's probably pretty small, but there's 4 cells queued that are about to run here. So you guys saw kind of the make prediction at the start. I have a different button down here called run on dataset that uses that same predict function that we had before. Um, oh, sorry, this is the run on dataset, but it iterates over a Parquet file, running predict on each row, and then adding the data back to a data frame so that we can see the results. And so I did that with OpenAI and with my 3 different models that I trained, the 1 epic, the 20 epics, and the 50 epics. And I started with, oops, let me go back, a test set here that is just like a list of things that we've tried to generate in the past. So for example, I just went down all of the blog posts that we've written in the past and grabbed whatever action we were trying to do here, like an ox cutting down a tree, or let's see, an ox sailing on a ship, or an ox pulling a cart of data, because ideally we just have all of these be the same branded character in the future. And so I put this all into a test set, so it was kind of like real world prompts that I would want to put into this model at the end of the day. So I have those scripts to run these models on those prompts. And so this is the OpenAI result set. Um, Pretty solid for all of these prompts. And then let's start with the single epic that was trained. Not bad for something that took a few minutes to train. It's like definitely picked up the ox character. You can see it has a hard time with some of the things in the scene. This one was an ox walking a dog. It didn't add the dog. It maybe made it half ox, half dog. This one's supposed to be training in the gym. This one's supposed to have a crab on its shoulder. So definitely learned the character, but maybe not all of the different assets that we put in the scene. Um, but if we train it for a bit longer, 50 epics, this is starting to look more like working on a workbench. This one's hammering nails. He doesn't quite have nails yet. Jump rope seems to be a hard one. I've gotten it to generate it in that like grid of 4, but it's kind of hit or miss. Baking a cake, still not walking the dog. The gym is better. We've got a barbell there. So overall, starting to get closer. But I think the really encouraging part here is now that we have like a supervised fine-tuned model that can get the right answer some of the time, that's like the perfect spot to be to put yourself in a reinforcement learning loop because you kind of want the model to get it sometimes and not get it other times, and reward it for the time that it does get it. So, uh, like I said, we're not doing the full reinforcement learning loop here, but I did want to do some proof of concept of how that could work. So if you remember at the closer to the start, I kind of had this diagram of, okay, let's take in an image, let's run it through a visual language model, and let's try to get some scores out of the end that we can use to guide the further training. So I wanted to see if this was possible at all or not. So I actually used Claude 3.7 Sonnet, which is a visual language model. I think there's a bunch that we could try to use here. Claude's probably a more expensive one, but I just wanted to see if we could get some sort of prompt that graded the images at all. Um, and so let's take a look at some of these. So here is our jump roping box. And you can see the prompt that I have here is you are an animator looking at an artist's work. Judge the following image on a few criteria. Be very critical. We're aiming for a movie quality character. Uh, each one of the judgments should be of these values: bad, okay, good, or perfect. And I give like a little description there. I find that sometimes using like an actual descriptive word instead of like a numeric value lets the model be a little more, lets it put these things into categorical buckets a little better. So we could just say return 0, 1, 2, or 3, but the words bad, okay, good, and perfect are a little more descriptive there. So those are kind of the categories that we'll be grading each criteria on. And then I have a bunch of different criteria. So is the character what we want? Is the task what we want? Are the objects what we want? Is the expression right? Is the texture right? Is the coloring right? Is the background right? So a lot of different things that we're grading this image on. And so we put in the prompt and we put in the image to that context. And then we get a prediction out from Claude that first has this little reasoning step here where it says, let me analyze the image according to the criteria. And this is nice at the start to kind of have you have a little look into what the model's thinking before it gets to its judgments at the end. But you can see this is actually a pretty good signal. So it says the character's good, the task is bad, the objects are okay. So I would say, yeah, we're like starting to get a jump rope, but it's not a full jump rope. Um, the expression is perfect. Yeah, I like the expression. Texture's good. The coloring's okay. Let's see. It says predominantly white, but there are some yellowish cream tones. So this is what I was talking about before of like sometimes OpenAI gives you this yellowish cream tone. I think we can fine tune that out in a reinforcement learning loop if we have a model that can detect it. Um, and then the background is perfect. So that's a great proof of concept that this is even possible. And I wanted to do a quick look at like what the distribution of those values were. So I wrote one final notebook to give us just like a state of affairs looking at one of those output data frames. So let me grab the 50 epic one for this score from judgments. And I'll kind of show you the motivation here after we run it. Oh, it should be in, it's actually in this judgments directory. This one. Oh, that was the 20 epic. Let's see. Let's just do this one. Okay. So this goes and downloads that, oops, that data frame. Sorry, my arrow keys got messed up here. That data frame with all of the judgments. And it looks like I exited that notebook. So let me go back into it. Um, it extracts for each one of the criteria is the character, the task, the object, the expression, the texture, and it just puts this into a nice, uh, you know, criteria per row for each one of them. And then it goes through and for each one of the things, it says, what is our percent perfect for all of those different categories? So we never got a perfect character. Claude never thought we got the task perfect, never got the expressions or the objects perfect. But you can see it's kind of like in the mediocre to good for a lot of these. So you can see bad is in red, okay is in yellow, good is in green, and perfect is in dark green. And I think this is a perfect place to start like bootstrapping that reinforcement learning because we can get okay to good pretty consistently. And if we're aiming for perfect, I think over time we can like shift these distributions to the right. Um, and if we wanted to see what that looks like compared to OpenAI, which would kind of be our goal or our gold standard, that looks like this, where like we have pretty good characters, we have much more perfect backgrounds, textures, and expressions, and much less in the bad category. So that gives me a sense that this LLM as a judge like is in the ballpark of the OpenAI ones are pretty good. Ours aren't perfect, but could have room for improvement. And this is what I want to put into a kind of a loop next time to see if we can bump our model up that curve. So that'll be one of the next dives. Pretty excited to dig into that. But overall, I think the kind of takeaway here is all you really need to do a fine tuning like this is uh, one reference image that you start with. So that one character that we did like, a prompt and a prompt to generate synthetic data. And I even got that prompt from the reference image. So technically you only need the reference image. And from there, you can start generating synthetic data, create a data set, fine tune your model, and you are off to the races. So what we're going to do with this is we have uh, the teams getting together for a herd house, we call it. And we're actually going to have each person or break into teams, have them find a reference image that they like, generate a bunch of synthetic data, and kind of put the teams head to head to see what characters come out the other end. So that'll be a fun little activity. And who knows, maybe it won't be this white ox that is the branded Oxen AI, but at least we have a framework for helping us get there. So with that, I'll stop sharing. If you're watching on YouTube, thanks for watching. I'm going to kill the recording and answer any questions for the people here live. Thanks, guys.